Farabi? Hello, Farabi. Farabi. Are you listening to me, Farabi?
Yes, sir. Yes, sir.
Can you see the screen?
Yes, sir.
Okay, now you read from the learning outcomes.
The
Here,
candidate should be able to describe a rise in temperature of body in terms of an increase in its internal energy, random thermal energy. Define
okay.
the
Now
term.
about this internal energy. Anything is written in your copy?
Sir, let me check.
Okay, open your copy. It's written. I uh, covered all the learning outcomes and I gave you this definition. What is called internal energy?
Sir,
Yes, sir. Yes, sir. Tell me, please.
heat capacity. Heat
Yeah, heat
capacity, the
capacity.
ability of any object to increase its temperature by 1 degree Celsius by giving 1 joule of heat energy is called heat capacity.
No, no. Before that, internal energy. Anything is written about internal energy?
Energy is the combination of potential energy and kinetic energy of atoms in a substance, rise in
Okay,
temperature
slowly,
of
slowly.
body.
Can you read slowly and loudly about internal energy? Again,
This
please.
energy is the combination of potential energy and kinetic energy of atoms in a substance. Rise in temperature of body increases its internal energy.
Okay, great. That one I need. So you understand what is called internal energy, right?
Yes,
And how internal energy increases. Look, in this learning outcomes, it's written also. Look, it's written here. Rise in temperature of a
rise in
body
temperature.
uh, increase its internal energy, right?
Yes, sir.
Yeah, why it happens? Because when you increase the temperature of a body, then the molecules or the atoms inside the body, they they have more kinetic energy, right?
Yes,
They start moving faster. If they are liquid, then they are moving randomly, right? Inside the liquid. If they
yes,
are
sir.
gas molecules, then inside the container their kinetic energy increases. If they are solid, they stay in one place, but the vibration of the molecules increases, right? That's why we say the kinetic energy increases. And if the kinetic energy increases, that means the internal energy also increases. Because internal energy is the combination or the sum of what? Potential energy and
Potential
kinetic
energy
energy.
and kinetic energy.
Great. So it's clear to you. Now next, heat capacity and specific heat capacity. Continue.
Heat capacity, the ability of any object to increase its temperature by 1 degree Celsius by giving it 1 joule heat energy is called heat capacity.
Yeah. So according to the definition, we are getting one formula here. Look, this
Yes,
formula you
sir.
got, right?
Yes, sir.
In your copy, it's
Thermal energy by changing temperature.
yeah, thermal energy equals what?
Change- Changing temperature.
Change
Heat
in
capacity
temperature.
equals thermal energy by changing temperature.
Yeah. So if you rearrange this formula, it comes like that, right?
Equals to, yes, sir.
Yeah. So this one is specific heat capacity, right? So there are
Yes,
two
sir.
things. One is heat capacity, another one is
Specific
specific
heat
heat
capacity.
capacity. So what is the difference in between these two, heat capacity and specific heat capacity?
Uh,
In your copy it's written, look, if it is only
heat
heat
capacity, the
capacity.
ability of any object to
Hmm.
to increase its temperature by 1 degree Celsius, and its specific heat capacity, the ability is the, the ability is 1 kg.
So heat capacity is for the whole object, right? The
Yes, sir. And the
complete
specific
object,
heat capacity
and
is, yeah, 1
is
kg.
for 1 kg. Very good. So in specific heat capacity, you are getting the mass in the formula, right?
Yes,
But
sir.
if it is only heat capacity, then you will not get it mass in this formula. Okay, that will be only thermal energy equals heat capacity multiplied by changing temperature.
Yeah, change the temperature.
So this thing you have to be clear that heat capacity and specific heat capacity, these are different, right?
Yes, sir.
So
Yes, sir.
specific heat capacity is for only 1 kg, right? 1 kg
Yes,
only.
sir.
1 kg object. I'm writing here so that in recording you get this 1 kg object. Then continue. You got one numerical question, right?
Yes, sir.
So this numerical question, which page and which problem from your textbook is written over there, right?
Yes, sir.
Can you open the book and check the question? Then you will understand the solution. You have the book with you.
Yes, sir.
Yeah, check. There is one numerical question we did there from your textbook.
Yes, sir.
Yeah, so please, you are sick, no problem. You go through all these notes, okay? So, uh, how long we can continue? Are you feeling really bad now,
Yes, sir. Yes, sir.
or we can continue?
We can continue.
Okay, we can continue. So, if we can continue, let's go for a while. Then we'll check that you are feeling okay or not. Then we will stop. No problem. Now,
Yes, sir.
look here, melting, huh?
Yes, sir.
And boiling. Okay, about this, in your notes there are some. You see some of the writings are available in your copy, which are related to melting, boiling, solidification, condensation. Can you check them? What is called melting?
Yes,
What
sir.
is called boiling? And there is also discussion about melting point, boiling point.
Yes, sir.
Yeah, yeah. Please
Melting,
check.
boiling, boiling point.
Yeah,
latent heat, specific latent heat.
yeah. Then evaporation. We discussed evaporation, right?
Evaporation.
And there
Yes,
also
sir.
we discussed the difference between boiling and evaporation. There are some points, right, in
Yes,
table.
sir.
Those are written right in your table. Yeah. Hello, Farabi, you got
Yes,
them?
sir.
Okay,
Yes,
then
sir.
you got this formula. Thermal energy equals mass multiplied by specific latent heat.
Specific latent heat.
Okay. What is the definition of latent heat given in your notes?
The thermal energy or heat required to change one state to another without any change of temperature is called latent heat.
So without any temperature change, only the state change, right?
Yes, sir.
Uh, so that one is called latent heat, because latent means hidden heat. We observe from outside the temperature is same, but it's still taking the heat energy, right? That's why it is called latent heat, and it's changing the state. It's going from liquid to gas. It's going from
Hmm.
solid to liquid, right? Okay. So when this state is changed, it requires some energy. That is called latent heat.
Latent heat.
Then you got some description about thermal expansion in solids, liquids, and gases, right? I gave you some examples, right, Farabi?
Yes, sir.
Okay. Then in solids, I gave you examples of railway track, right?
Yes, sir.
And then the lid of a met metal lid of a glass jar, right? That one.
Yes, sir.
Then
Yes, sir.
sagging of electric cables, right? Then liquid.
Yes, sir.
We gave the example of liquid in glass thermometer, expansion in liquid in glass thermometer. Then we gave the example of hot uh, air balloon, right?
Yes, sir.
So that one, how the balloon is rising up with the change of density. That one due to the thermal expansion of gases. That one also we discussed, right?
Yes, sir.
And these all are some everyday examples and applications of thermal expansion. Then we have some worksheet. I gave you the worksheet on this topic. Can you remember? I
Yes,
gave
sir.
the worksheet on. Also, I gave you the mark scheme of MCQ part in your
Yes,
messenger.
sir.
So our notes are available. Your textbook is available. Please go through. Right? Please
Yes,
go
sir.
through your notes. If you have any doubts on Saturday, you ask me that this one we need more explanation, or during the worksheet solution we have more discussions. You will understand that
Yes,
time
sir.
all these things more clear to you, because we
Yes,
will
sir.
discuss all the questions in the worksheet, so that you understand all the ideas. You can apply all the ideas you got here. And it's a big worksheet. In this worksheet you will get a lot of questions, lot of ideas. Okay, now I'm
Yes, sir.
opening the worksheet. Check the
Yes,
worksheet.
sir.
Here is the worksheet. Can you see the worksheet? Hello.
Yes, sir.
Okay, can
Yes,
you
sir.
read the question, first question?
The diagram shows four changes of state W, X, Y, and Z. Which row gives the names of four changes of state?
Yeah, so we have here gas, then liquid, then solid, right?
Yes, sir.
And from gas to liquid, it's showing X, right?
Yes,
Then
sir.
when it is liquid to solid, then it's showing Z.
Yes,
Then
sir.
from solid to liquid, this is Y. Liquid to gas, it is W, right?
W.
So let us think about Y and W first, right? Because
Yes,
it's
sir.
very simple to understand that from solid to liquid, when one solid is going to be liquid, that time this process is called melting, right? Like
Yes, sir.
ice. Ice melts and it turns to water. So
Yes,
Y
sir.
is melting, right? Hello, Farabi.
Yes, sir.
Now we are writing it here. Y is melting. In your copy, you can write worksheet
Yes, sir.
11, MCQ 1, then process Y is melting. You please write it, huh? Then you can remember
Yes,
when you
sir.
see the worksheet. You have printer in house.
No, sir.
You can take the printout if you say your
Yes,
parents.
sir.
If it is
Yes,
possible
sir.
to take the printout,
Yes, sir.
please take the
Yes, sir.
printout. Then it will be better for you. Then you can have some notes.
Yes,
Then
sir.
tell me if it is from liquid to gas, then which process? Is it condensation or boiling or it is freezing? Which one?
Liquid to
Liquid
gas.
to gas. Yeah, which one? From liquid to gas. What is this process?
Sir, yeah, boiling.
Very good, very good. So it's boiling, boiling. You should write here it's boiling. Now can you tell me from gas to liquid what it is?
Evaporating.
What?
Sir, evaporating.
It's gas to liquid. That means
Okay.
it's turning from vapor to water. That
Yes, sir.
time what happens? It's called
Condensation.
condensation. Condensation. Okay, what is called?
Condensation.
Yeah, this one is condensation, right? I'm showing with arrow. Okay, directly from there. Now, from liquid to solid, what it is?
That's
What it is?
freezing.
Freezing. Freezing. So, which one will be the correct option? Think and tell me. Which one is
Yes,
given
sir.
the all the columns correctly? Already
Sir,
I
D.
told you Z is freezing, right?
Sir, D.
D, excellent, excellent. W is boiling, then Y
H is
is
condensation. Y is
melting,
melting.
yeah.
Z is freezing.
So D is matching with all, right?
Yes, sir.
So this worksheet I gave you, right?
Yes, sir.
And also I gave you the mark scheme in the group. Okay,
Yes, sir.
today I will only upload the worksheet in the Google Classroom.
Yes, sir.
Okay, then you try how much is possible. Okay, I think from the first question you understand how to deal with the MCQ questions, right?
Yes, sir.
So this way you can continue other questions as well. Right now, should
Yes,
we
sir.
continue question 2 or will stop the class now?
Stop the class.
Okay, you are feeling sick. So that's your homework, right? You
Yes, sir.
you don't take load. Uh, do how much is possible for you. If you can solve 10 questions, do 10. If you can solve uh, more than 10, solve them. No problem. Okay. Try at least 10 MCQs. Okay.
Yes, sir.
Clear, Farabi?
Yes, sir.
Okay, thank you so much. That's all for
Welcome.
today. Thank you for
Yes, sir.
joining. Allah Hafiz.
Allah.